In this recording, we're going to introduce some of the fundamental concepts related to functions. So some of this might be a review for you, some of it might be brand new. We're going to start with the term relation. A relation is simply a set of ordered pairs. You've got one right here. This is a set of ordered pairs, a bunch of points, really. Okay, so you can jot down that definition. It's a set of ordered pairs or points. Okay, when you've jotted that down, you keep going here. This is a discrete relation, one that has a finite number of points. You can see it only has 4 points. Okay, a discrete relation only has has a finite number of points. Could be 4, it could be more, but there's a countable number of points. All right, and I'd like you to plot those points on this axis and play the recording when you're ready to proceed. Okay, so check your work there. I've plotted the 4 points. You can see that, well, some of them have a repeat x value. You know something about that, I hope, from a previous math class. And some of them also have a repeat y value, and that might be a new term that we're going to introduce later in this lesson. So next we're going to look at example 2. It's a continuous relation. Okay, this is just fancy notation here. If this throws you off, what it's basically saying is the relation B is a relation between the points, the variables x and y, such that, that's what that vertical bar means, such that y is equal to 2x plus 1. Now this right here looks very familiar to you, right? This notion of 2x plus 1. This kind of throws you off a little bit. You're not as comfortable with the notation, but okay, you've learned new stuff before. You'll learn this. So it's a relation of the variables x and y such that y is equal to 2x plus 1. So let's graph this relation. Go ahead and pause the recording and make that graph. You could either do that by getting a table of values, or you could use the slope and the y-intercept, whichever works better for you. So I've got the line plotted here. I started by plotting the y-intercept of 1, and then I used the rate of change, the slope of 2. I went up 2 over 1, up 2 over 1, etc. So I got my line. So what is the difference between these two types of relations? The one that was discrete in example A, that was just 4 points, and this one in example B that was a line. Why don't you use your words, write down what you observed, and then play the recording. Okay, so there's a couple ways to say it. One way would be simply a discrete relation, that was like the first one, has a finite or countable number of points. They're not connected. Whereas a continuous relation, like the second example, has a graph that looks like a line or a curve. You can't count all the points because there's an infinite number of points between any 2 points on this grid. Okay? Next, we're going to consider particular parts of a relation. Remember, a relation is what? Just a bunch of points, right? Set of ordered pairs. This is that right here. This notation right here, this set bracket, just indicates that we have a set. And a student one time taught me this. I think it's excellent. If you're having trouble making that set notation, you make an S, and then you make a backwards S. I thought that was pretty good. And then to make the right set bracket, you make a backwards S, and then you make an S. All right, so practice that a little bit in your margin. You'll be very good with this. All right, so what is the domain? I think you remember that that's just the set of x values, or the inputs into a relation. So once you've jotted down that definition, please write in this space what is the specific domain for this relation. And remember, we're not going to repeat any values in the domain. So jot that down when you have it. Okay, so here's the domain. Notice that I did not repeat. -2 appears twice as an x value. I did not repeat that. All right. Now for your range. You probably guessed what the range is. Why don't you write down your definition of the range? It's very similar to this one with one small change or a couple small changes. And as you may have guessed, the set of y values or outputs in a relation is the range. All right. And do the same for the range. Jot down after the definition, jot down the specific set of y values for this relation A, and then play the recording, please. Notice how I didn't repeat that 4 as a y value, I only wrote it once. All right. And finally, why would it be more difficult to write the range and domain for the example 2 as compared to example 1? Remember we had that line versus those points. There's lots of ways to describe this. Use this space to write out in your own words. Don't hear my definition or explanation until you've written it out in your own words. All right, so one way to explain this would be just to say it's not possible to list all the points in a continuous relation, right? It's infinite, so you can't possibly list them out like this, so we need another way. And to do that, we're going to use something called interval notation. All right, so this is going to be a little self-teaching, little self-study. What I'd like you to do is read through this, read through these first couple examples, and then play the recording and we'll talk about it. All right, so you're familiar with this notation, just x greater than 5. This is equivalent. Let's talk about what that looks like in a graph. I like to make a graph as a bridge between the two notations. So we're going to start with 5 and make an open dot, because 5 is not included. It's just the numbers greater than 5. And if you remember, we're going to sketch there a ray to the right. So interval notation at first might be a little tricky for you because it's brand new, just like anything is new that's tricky. But I think you'll grow to appreciate it, especially as our sets get more complicated. So interval notation just always has a starting point and an ending point. So the starting point is 5, and the ending point, well, there isn't one, right? It doesn't end. It just keeps going and going and going, so we call it infinity. And then you have to decide what kind of bracket you need on the sides. So if it's an open dot or not equal to, notice there's no line underneath here, then you're going to put a parenthesis. And if it's infinity, you always use a parenthesis. All right. The square bracket you're going to learn about next is for a filled-in dot. So let's read about that next. Okay. The square bracket you're going to read about, and we can graph it in a similar way. We can graph it by making a filled-in dot at 5, and this is saying greater than or equal to 5. So this would be equivalent notation for these three representations. All right. Why don't you read that, and then I'd like you to come down to this next one and make the graph, and then express it in interval notation. Okay. Pause and do it on your own. All right, so hopefully you read about that and you got to the point where you made this graph. It's from 5 to 7, but not inclusive. So we've got open circles, a little segment in between. So again, interval notation, just write 5, 7. Those are our two endpoints, minimum, maximum. Then you have to decide what kind of bracket. It's a parenthesis for each of them because it's not equal. All right. Now we've got 5 to 7 again. So, but this time 5's included. 7's not. Array. But we're going to write it this way. Square bracket on the 5, parenthesis on the 7. Okay. Finish up by looking up this last one. Do it on your own, then play the recording, please. All right, so for this one, 5 is included. 7 is also included. Not sure why that one came out black and that one blue, but that's just how it came out. All right, so we're going to go from 5 to 7. You got a starting point, end point, brackets. Notice how if it did go to infinity, you would always use a parenthesis. That's at the top of the page. Okay, and what if finally it doesn't have an upper bound or a lower bound? In other words, this entire line, well, then you would say it's from negative infinity to infinity, or all real numbers. Okay, so now to finish up, you've got a little practice. So work on these problems, make a number line if needed, and then I'll give you some chance to check your answers. So you can check your answers here, being particularly careful to how you're making your brackets and your parentheses. Make sure those are written clearly. Notice how we always use the parenthesis for the infinity. And for the final example, you're going to have negative infinity to infinity for both the domain and range because there's no limit to the x's or y's of that line. Thanks for watching.